Our testing setup is now ready to go. We're now going to very quickly come back to the age-old question that arises anytime we start to write tests. And that question is, what tests should we write? That's the question. That's what everyone always gets confused about. So remember, whenever you start writing tests, I really encourage you to just answer a simple question to yourself. Ask it and answer it. What behavior do you really care about with this contract? When I start looking at the lottery, I start thinking about the enter function right here. And at a very low level, well, we probably want to make sure that anytime someone calls enter, I want to really be 100% certain that their address gets added to the player's array right here. I think that's really ideal. I want to make sure that if anyone calls enter and they send in the correct amount of money, which is at least 0.01 ether, I should see their address get added. I think that's a very reasonable first test. Let's just attempt to enter into the lottery and then assert that this player's address appears in the player's array. And you will recall that we can access the player's array by using the getPlayers method that we added down here. So let's give this a shot. Back inside the test file, I'll add on my it statement, and I'll give it a description of allows one account to enter. I'm going to mark this function as being asynchronous because it's definitely going to have some async code inside of it. Inside the function itself, we will then immediately attempt to enter into the lottery. So I will say await lottery.methods.enter and .send. Now in this case, we want to make sure that we specify who is attempting to enter into the lottery, and we also need to make sure that we send along at least some minimum amount of ether. So we'll first start off by specifying who is attempting to enter. So we'll say from accounts at 0. And then secondly, we need to make sure we send along some amount of money with this transaction. In order to send along some amount of money, we need to specify the value property. And assigned to this value property will be the amount in way that we want to send along. Whenever we specify way, we use a string and then we enter in the number of way that we want to send. Now you might be thinking that we're going to write out the amount in way in as 1 and then many, many zeros. Because remember, we need to send along at least 0.01 ether. But rather than trying to write out 0.01 ether as a string like so, because that's really easy to make a mistake on the number of zeros we pass in, we will instead use a little conversion method that is included with the Web3 library. This method allows us to specify some amount of ether, so like units of ether, and automatically have that converted to the appropriate amount of way. So we can reference web3.utils.toWay. Then we pass in the amount of ether that we want to contribute as a string. So 0.01. And actually, you know what? We need greater than 0.01. So let's do 0.02, like so. And then we need to specify the denomination or the units for this 0.02 right here. This is supposed to be ether, so I'm going to pass in ether as a second argument to the two-way function. The Web3 library will take the 0.02 of ether and then return the equivalent amount in way. So again, this entire function call right here is to just keep us from having to manually count out the 2000000, however many zeros we should have. And it's also much more legible. All right, so that's going to enter us into the lottery. Immediately after entering, we should be able to attempt to call the getPlayers method right here and get back our list of players. So this will be an array of addresses. We can then make sure that the appropriate number of addresses is present inside this array. So we can say const players is await lottery.methods.getPlayers.call. And we'll make sure we specify who is calling this function. So say from accounts at 0. Don't forget the await keyword right here, because of course this is an asynchronous method to attempt to reach out to a contract and obtain some value. So now players should be an array, and the only element inside that array should be the address of accounts at 0. So we can now write two separate assertions. One that will make sure that there's only one record inside the array, and another to make sure that the correct address is stored inside. So we can say assert.equal accounts at 0, so that's the value that it should be, and players at 0. That's the value that it actually is. We can then say assert.equal players.length. Oops. So it should be 1. That's going to be our first argument. And then comma players.length. Remember, it's always the value that it should be and then the value that it is. So that was my mistake, putting the 1 last. All right, so let's save this and run our tests again, see how we're doing. So I will npm run test. That'll start our test back up. We should now see 2 separate tests passing. One for deploying a contract, and then one for allowing our account to enter. At present, we're not actually making any other assertion beyond this one account, and that's why I specifically specified in here one account. We can certainly come back and add in another test that then attempts to enter in 2 accounts. Of course, there's no issue with that whatsoever. All right, so back over at the terminal, it looks like our 2 tests are passing. So that's great. Let's pause here. We'll continue in the next video, and I think that we will do that additional test, something to make sure that we are able to enter with multiple accounts and make sure that each of those addresses get stored in the players array. So let's take care of that in the next video.